Thank you for joining us this morning for the next installment of our IEC webinars. Presentation itself is roughly about 15 minutes, and if you have any questions, we can get to those at the end.
Welcome to today's tutorial. Let's get started. So let's have a look at our agenda for today. Today, as part of our IEC support series, we are looking at using Advanced Sequential Function Chart or SFC techniques in Cscape. First, we'll do a quick review of SFC and the start-stop control logic that we created in our previous webinars on IEC that we'll be working with today. Then we'll look at some advanced techniques, beginning with timed transitions and then moving on to divergence and convergence, which we can use to create some more advanced logic using SFC. We'll have demonstrations throughout, and as always, we'll finish with a Q&A session. First, let's do a quick recap of the SFC logic we created in our previous webinar on IEC. We first looked at SFC in IEC Support Part 1, which you can view from the webinars section on the Horner website. In that initial demonstration, we created some stop-start control logic. SFC is made up of a few main components: steps with associated actions, transitions which have associated logic conditions, and finally directed links between the steps and transitions. Steps in an SFC diagram can be either active or inactive, with actions only being executed for active steps. A step becomes active when all the steps above it are also active and the connecting transition's associated logic condition is true. When a transition is passed, all steps above are deactivated at once, and after, all steps below are activated at once. So looking at our original start-stop application, which you can see on the left, here step 1 is the initial step, which is active when the OCS goes into run mode, which is indicated by the double border around that step, and that is the machine's stopped state. The logic remains in that stopped state until the B start signal becomes true. With that, step 3 now becomes active, and step 1 inactive as transition 2 is crossed. Step 3 indicates the machine's running state. Step 3 remains active until the B stop or B emergency stop signals become active, at which point step 3 is deactivated and transition 4 is crossed. Then the jump returns us to step 1, which is the machine's stopped state. B start, B stop, and B emergency stop are Boolean variables driven by K1, K3, and K4 respectively. B running is a Boolean variable driving Q1 as well as a lamp on the initial OCS screen. With that in mind, let's move on to our advanced SFC techniques. The first SFC feature we're going to add to our initial functionality is the timed transition. So we're going to add an additional step which will execute prior to the machine starting. This will be used to prepare the machine for running, perhaps turning on a B warmup output just prior to the machine actually starting. So let's go through that process of adding that to our application. So first we'll highlight step 3 in the SFC and then click the step button. The new step is added along with a new transition which will move us from the new step to the original running step. You'll then notice that the numbering for the steps and transitions will be out of sequence. Although this is no problem in terms of execution, you might wish to use the renumber button to bring the numbering back into order. Then we'll add a new variable bWarmup in the program variables window and map this to the output Q2. We'll add bWarmup equals to false in the P1 tab of the initial step, which is step 1, and add bWarmup true in the P1 tab of the newly added step. Then we'll select the newly added transition and click the Add Timer on Transition toolbar button. In the popped up spin control, enter 2000, as this sets a time in milliseconds after which the transition will automatically be triggered. Your logic should now appear as shown on the right, assuming that you renumbered. Then we'll add a lamp to the display to show the initializing status. And finally, we'll download and test that operation. Now let's demonstrate that process for adding that time transition in Cscape. So starting with our original start-stop application, we're going to add a warming up phase to the machine cycle, which will be active for 2 seconds before the machine actually starts. The first stage to implement this is to add a new step to our SFC diagram. By selecting our old step 3, which was previously the running state, we can click on the new step toolbar button. The new step is added, which will be our warming up step, and additionally a new transition will be added, which will transition us from warm up to the fully running state. Note how the numbering for the chart is now out of order. Obviously this is not a problem in terms of operation of the SFC, but for readability we may wish to get the steps and transitions back into a logical order. In order to do this, we can click on the Renumber toolbar button, which I have done already. The next step is to go to my global variables, my program variables window, and create a new variable which I'll call bWarmup. That's a Boolean variable, and I'll map that in my memory column to Q2. With the new variable declared, we'll add logic to the chart to maintain the variable. First, let's go to step 1, which is the initial step for the chart. We can add the statement bWarmup set to false in the P1 tab of the step. This makes sure the warm-up output is always turned off when the OCS goes into the running mode. Next, we'll go to the warm-up step, step 2, and add setting bWarmup to true in the P1 stage of the step, turning on the output when the warm-up step is entered. Then we'll set bWarmup to false in the P0 stage of the step, turning the output back off as we leave the warm-up state and enter the full running state. We now want to transition from step 2, which is our warm-up, to step 3, which is our running state, 2 seconds after the warm-up started. You'll notice that at this point all the toolbars in the SFC toolbar to the left of the diagram are disabled. This happens whenever any of the secondary step editors are open. So let's close the step 1 and step 2 editor windows and see the toolbar buttons become enabled again. Obviously we'll need to save the changes that we've made. We'll now see all the toolbar buttons enabled again, so let's select transition 2, which corresponds to warm up to running mode, and then click on the timer transition toolbar button. We'll enter 2000 in the box which pops up, which corresponds to 2000 milliseconds. So after 2 seconds of warming up, we'll enter running mode. Finally, we'll go to the graphics editor and add a lamp to indicate the warm-up status of the machine. Here I'd already previously created a lamp to show the machine was running. So I'll copy and paste that, and then I'll double click here, and then I'll change my variable from bRunning to bWarmup. Then I'll go into my legend and I'll change that from machine running to machine warmup. With the changes in place, we can now download this to the OCS and see the functionality in operation. Here is my program running on my OCS. So when I trigger my warmup, the machine warmup lamp turns on for 2 seconds before my machine transitions to its running state, indicated by the machine running lamp. Then I can press key 3, which is mapped to my bStop variable, which returns the machine to its stop state. The next feature we will look at as part of our advanced SFC techniques is divergence and convergence. Building on that application we were just working with, we're now going to add a push button which from the stop state will run an auto clean cycle in the machine. We'll do this using the divergence tools in the SFC editor, which are highlighted in the editor view on the right. So let's look at that process and then we'll go into a demonstration. So first we'll add new variables for the auto cleaning, which I'll call bStartAutoClean mapped to K2 and bAutoClean mapped to Q3. Next we'll highlight transition 1 in the SFC and then click the upper of the 3 divergence and convergence buttons highlighted. Next we'll select the cell to the right of the newly added divergence and click the middle of the highlighted buttons on the toolbar. Below this cell we'll add a new transition and we'll make the bStartAutoClean variable the condition for this transition. Below this we'll add an additional step. This will also automatically insert a transition for leaving the new step and will set this transition timed at 10,000 milliseconds. Then we'll click on the jump to step 1 at the bottom of the chart and again click the upper of the 3 highlighted buttons. Then we'll select the cell to the right of this and click the bottom of the 3 highlighted buttons. The chart should now look like the chart on the right. Then we'll add logic in the P1 tab of steps 1 and 101 to set B auto clean false and true respectively. Then we'll add a lamp to indicate the B auto clean output on the screen. Then finally we'll download and run that updated project. So now let's demonstrate that process in Cscape. We'll start by adding 2 new variables, B auto clean, which is an output which turns on during the auto clean stage and drives digital output Q3, and then B start auto clean, which is a keyboard button to initiate the auto clean process. In my memory column, I'll map that to K2. The auto clean may only be started when the machine is in stopped mode, and on completion will return the machine to a stopped state. So this can be implemented as a parallel set of steps to the current run control logic. We'll begin by selecting the current start transition and then clicking the Divergence toolbar button. This starts the parallel branch. Next we move to the right of the divergence and click the second of the divergence buttons. This starts a second parallel branch coming down from the first one. We can now add the transition to start the parallel auto clean branch. Then I'll add the step which is active for the auto cleaning cycle, and finally the transition which exits the auto cleaning branch. Then at the bottom from my jump I'll add another parallel branch. Finally we'll add a convergence so that the 2 parallel branches both put the machine back into the stopped state once completed. So then in P1 of the machine's stop state, which is step 1, I'll set B auto clean to false. Then in P0 and P1 of the auto clean step, I'll add more logic. I'll set B auto clean to true in P1 and to false in P0. So the auto clean output is set to off when the device enters run mode and switches on as we start the auto clean, and then off again once the auto clean is complete. Once I have that complete, I'll exit out of these windows and save any changes that I have made. We can now add a timed transition for transition 6 to ensure that the auto clean runs for 10 seconds. Then in transition 4, before my auto clean step, I'll drag in the B start auto clean variable and use it as the signal which starts that auto clean cycle if the machine is in a stopped state. Then I'll do a quick error check, and as you can see there are no errors. So now I'll go into my graphics editor. I also want to make a lamp on my OCS screen for my auto clean, so I'll go ahead and make space for that here. Now you'll see the lamp in this object is quite small, so I'll double click and go into this object, and then I'll go into the legend and lower the font size. Now you'll see that that lamp is bigger. And now I'll make this object smaller, and again I'll go into the legend and then I'll lower the font size. Next I'll copy and paste this object, and then dragging it down here I'll double click and go into the legend, and I'll change that to machine auto clean. Then I'll tie that object to the B auto clean variable. With these changes in place, we can now download this to the OCS and see the new functionality in operation. So here is what that could look like on the OCS. So here I'll press key 1, which is tied to the B start variable. That triggers my machine warm-up, which after 2 seconds transitions to my machine's running state. Then I'll press function key 3, which is tied to my B stop variable, and then I'll press key 2, which is tied to my B start auto clean variable, triggering the auto clean process. That lasts for 10 seconds before returning to the machine's stopped state. That is our demonstration complete. Thank you for joining me for today's tutorial, and the Q&A session will begin shortly.
Okay, nice and straightforward for you this morning. So next week we have user security, and that's followed by a bootloader recovery tool. And that'll take us for the next 2 weeks, and you can see the upcoming webinars past that and all the past webinars. Other than that, thank you all for joining us this morning, and we hope to see you again next week.